In today's lesson, we are going to be reviewing kinetic energy, potential energy, and total mechanical energy. For the most part, this is review. I did want to go over one problem with you because it kind of combines everything all together, and I want to make sure that you have an example of how to do it correctly so that you know what you're doing. All right, so for number 6, it says an earthquake has caused a rock to roll off the top of a cliff. When the rock is 16 meters off the ground, it is moving at a velocity of 32 meters per second. The rock has a mass of 10 kilograms. How much total mechanical energy does the rock have? So we have a few pieces of information here, and we have plenty to solve the problem. So the first thing I'm going to do is I'm going to collect my variables. I have a height, 16 meters off the ground. So my height is 16 meters. I have a velocity of 32 meters per second. And I have a mass of 10 kilograms. I want to know what my total mechanical energy is. So total mechanical energy equals potential energy plus kinetic energy. We can also say that total mechanical energy equals mgh, which is potential energy, plus 1/2 mv squared, which is kinetic energy. So all I have to do then is plug in the numbers that I already have. And I want to do this separately and get an answer, and then have this separately and get an answer, and then add those two answers together. So what I'm going to do is I'm going to do 10 kilograms times gravity, which is 9.8 meters per second squared. And I'll add that over on the side, plus height, which is 16 meters. So gravity, we always know, is 9.8 meters per second squared. And then I have my kinetic energy, which is 1/2, times my mass, which is 10 kilograms, times my velocity, which is 32 meters per second, and then I square that. Now, the answer here, when I do 10 times 9.8 times 16, I get 1,568 joules. 1,568 joules. And then here, when I do 1/2 times 10 times 32 squared, and remember, do the 32 squared first, and then times it by 10, and then times it by 1/2. You should get 5,120 joules. And then we add those two values together, and we get 6,688 joules. And that is our answer. That is our total mechanical energy. So I'm just going to get out of the way so you can take a look at exactly how I did that. If you have any questions, again, feel free to email me or email Ms. Schoon. Let us know what you have problems with, and we would like you to finish the rest of this on your own. Most of it is review, and again, we're just putting these two things together.